So welcome to a new tutorial in our learning series, and this one is for the Flip Fluid Simulator as well as for the Blender Fracture Modifier in combination. So to be able to do something like you have seen in the intro of this video is you need to buy the Flip Fluids add-on that is available on the Blender market, and you can visit blenderphysics.com and click on Fracture Modifier to download your custom build. Okay, once done, everything is set up. We are here. You open the Blender Fracture Modifier Build and make sure everything has been installed, like in the introduction videos. And then here we go. So basically, I start with this scene. It's a standard thing. Let me delete the default cube here. And what I have here is my ground. It's a downscaled cube, and make sure it has a rigid body on it that is passive. So we have a collision ground for our animation. And first thing we will do now is we will make something like a glass. I'm going to use a cylinder for this. And yes, rescale it a little bit, also to the Z direction, and let's put it to the ground. And I found a very useful plugin or add-on for this, and it is called Drop to Ground. You can find a version that will work with the latest Blender build. Maybe if I find time, I will make a download link for you on blenderphysics.com. But now let me show you how it works. While your cylinder is selected, select also your ground and then type in drop to ground. And then this will be perfect on the ground. Very great. So let's go and rename this stuff here. This is glass. This is ground. And yeah, this is lamp. We don't need to rename it. Okay, so it's very important to use the right order when going to simulate the stuff here. And please follow the steps each by each, otherwise you will have some trouble with simulation and rendering, but I will explain this now more in detail. So let's finish our glass here. What we would like to see is something where we can fill with fluid in, and that means we have to remove the face on the top. So while being in the edit mode, go and select the upper face, and let me delete this one, and now we can put water in here. So what is important to know is in general the Flip Fluids add-on is not made for that kind of simulation. It's more for large-scale fluid simulations, and there's an issue with thin objects. What means when you're going to simulate now water inside that glass, the water will drive through its walls here, and we need to give that object more thickness using the solidify modifier here. And badly, it has to be really thick. Let's say, like, I would say this will work, but we also need another one with more thicker walls to make this stuff working like we would like. So I would say we could directly make a duplicate of this here by pressing Shift and D, and let's call this glass outer, and we will reverse the thickness here, so something like this. Let's say negative 0.5, something like this. This object will not be rendered, and you will not see it in the final render, but it is required for the fluid simulator to avoid fluids to come through the wall. So this is a trick we are doing here. This will be an obstacle, and we are going to animate this obstacle to to make it not visible in the fluid simulation as well as in the rendering. Okay, so for that we make this invisible. Oh no, one more thing. In wireframe, make sure this fits perfectly into your glass. So yes, I would say you can see where the edges of our original glass are and of our obstacle object, but this will work, yes. Fantastic. So this is what is required. Another thing is we want to shade this one smooth. Yep. And let's go and give that a material. I love to do this in the rendered mode to see what is happening here. So new, let's call this one glass. And of course I'm using a glass shader. So now you can see a problem where we'll drive into. Wait, let's make this a sun and not that bright. Something like this. Why is our glass black? I'm not really sure. It has to do something with the smooth shader, I think. And a way to make this look better is to use a edge split modifier. But the problem is when you use the edge split modifier, the flip fluid simulator will have trouble with this. That means before we are going to simulate our water, we have to remove the edge split modifier to make it work correctly. But that is not really a problem because we can add this edge split modifier after we have finished baking. Okay, so this is our glass here. Not the most beautiful. You can take more time to make it look beautiful. But for this tutorial, and I want to keep it as short as possible, that will be enough. Okay, so let's go and fracture this glass. So I'm clicking here to the physics tab and click on fracture and just hit execute fracture. And now this is looking like this. Does not look correctly. This is because we have to fix the normals here, and the fracture modifier has a toolbox for this. We will find it here. Let's search for fracture utilities. This tab here. You can click on fix normals. All right, and then execute fracture again. It's also important to do this first because we need to bake this fracture simulation before we bake the fluid simulation. And once this has been baked, you cannot click on fix normals because that would mean you have to refracture your object, and that would mean you have to rebake your object. So make that first when we're going to make that stuff here. Okay, let's move this here. We need a bullet. I'm going to use a UV sphere. I'll resize it and let's say your bullet. All right. Looks great. Something like this. And this bullet will fly through the glass. No, let's move this here. Because all the stuff will fly around here. Okay, I'm sorry. So, yes. Make sure your bullet will fly through the glass. So bring it in position. And now let's think about how fast that bullet will fly. I would say it will take, let's say, 1 second from this side to the other side of the glass. And this depends on which frame rate we are using. I would like to use 50 frames the second because that gives us a more accurate physics simulation as well as a more smooth final animation. 50 FPS is great. Make sure you use something like 500 frames in your general animation settings because otherwise it will break up too early, maybe. And let's go to the physics tab here and configure the Rigidbody word. So I would say solve iterations should match your frame rate, and steps per second would be twice of this. And in my experiments, that looks best. And the Rigidbody cache, make sure it matches your render settings too, because otherwise it will stop earlier before your general animation has been finished, and that is really something that can drive you crazy. Okay, so 500 here, 500 there, everything has been set up now, and let's make a keyframe animation for our bullet here. I'll bring it back to this side because of the camera. So here, let me resize this a little bit. This, yeah, that could work. Okay, so let's set a keyframe for this here. And as I told you, 1 second means 50 frames. So let's go on the other side. Of course, this is now moving because the fracture modifier is on it. Not a problem. Set a new keyframe here, rewind, And what I do not like now is that the sphere starts moving slowly, becomes faster, and stops moving slowly. We have to change the interpolation of this now by using the graph editor. And while everything is selected here, click on key, click on the interpolation mode, and click on linear. So we have a linear motion. It's always the same speed. That is what we would love to see. Okay, now get back into our fracture modifier settings. So this is our glass here. You could take a deeper look into while using the toggle wireframe button here, and you see how this one is looking like. For me, it is not looking fantastic. They are all everywhere big shards, and this is not what I really would like to see. I want to have smaller shards on collision points, and as you maybe know from other tutorials, this is very easy by moving your object into the glass. And while this is selected, also select the glass, and then on the left side in the Fracture Helper add-on, you will find the Generate Smaller Shards panel, and click on Generate Smaller Shards, what will make an invisible duplicate of your bullet here, and gives it a particle cloud, and the fracture modifier can use this particle cloud to generate smaller pieces here, and so on and so on. And of course we need the same on the other side of our glass. A very cool and simple way to do this is just duplicate this one by hitting Shift D and move it to this side. Because by duplicating a helper object, it will automatically be connected to the fracture modifier, what means you just have to refracture, and then you will see you have small pieces on both sides. And I also would say in general we do not need that many pieces here. So as you maybe know, you can use the shard count here to choose yourself. So let me show you. If you choose to use 100 shards, you will see more pieces everywhere here, but we need something like 2. Great. And in general, without this helper, you would see 2 pieces, just 2 big pieces. But because we have that helper objects here that generate smaller pieces, you will see more pieces everywhere around here, what is realistic. Okay, so now when you play the animation, you will see the glass is falling directly. It's really not what we would love to see. And what we need to do is we make this glass animated, so that means nothing will happen, and we need to make this one a triggered one. Now nothing is happening too, because a triggered object is waiting for a trigger object. And what is our trigger object? Yes, our bullet. So make this one a rigid body. It's an active one, it is an animated one because we used keyframes, and it is our trigger object. And now play the animation, you will see this is looking like this. Very cool. Okay, I'm still in love with this animation. You could small down this thing a little bit, like this. You see some holes here, and it depends on what you would like to see. You could now use this object and this simulation as it is, but you could also use constraints to make bigger pieces falling down too. Of course, it's a little bit complicated for someone who never used constraint, but in general, this is a really easy thing. But I'm sorry, I'm not going to explain in detail how constraints will work, because I'm working on a special tutorial for this. So I would say just copy what I'm doing here for your simulation and wait for the new tutorial. Okay, so let's use constraints. Use constraints means we need to set rules for these constraints. Something like when pieces should start to crack off, and let's say by an angle of 1. You can check how this is looking like. Yes, it's not happening much yet. That is okay. You can slow down the angle here and see that is looking a little bit better. Sometimes it's required to decrease the search radius. So let's take a look what is happening there. Okay, and what we will do also is we are going to use clusters. Clusters means a cluster is something that holds all pieces inside, something like gluing them together. Let's say you have 100 pieces here and you have one cluster. That would mean you have one cluster with 100 pieces. But by using a cluster count of 2, that would mean you have 2 clusters where each have 50 pieces inside, and so on. And you can set rules for these clusters too. Take a lower value here, like 0.1. I would say when this has been done, you should execute Fracture. I'm not really sure if this is required, but just to make sure everything will work. So play this animation again. And another thing I would love to do is I'm going to activate broken. This is new for many people, I think. Activate broken will activate other shards that are not triggered by the triggerer after the triggered object had been triggered. Wow, what a sentence. Okay, so let's go and take a look how this will look like. And I would say that looks fantastic. That looks fantastic. Now you can play around with these rules here. You can do some experiments, but make sure, oh yeah, that looks really good. Oh yeah, I think that is something we are going to use now. This flickering will not be visible in the final render. So when that has been done, you should save your file. Okay, so go save as, and I would say this is, oh yeah, I did some tests before, so let me rename, make a new one. Flip fluids, fluids. Oh damn, flip fluids and FM. Okay, save as blended file. And when you have done this, you should bake this simulation. So type in bake, and if you don't know what bake is correct, you should use this PT cache bake. Where is it here? PT cache bake all physics is the correct one. Click on it and then wait for the progress to finish with 100%. And when that's had been done, you can see what's happening here. You can scrub through your animation line here, and yeah. So our fracture simulation has been finished. Very, very cool. Okay, I'm going to save this again because I want to make sure that the baking has been saved too. So click on save. And I'm going to show you now another thing while being in the rendered viewport shading mode. As I told you, you know what you have to do with to avoid the glass to look like black glass. So as you can see, you can now add where is it, the edge split to the glass after baking it. That is not a problem, and you will see you have all you can see the shards here. So the pieces are, of course, this is a pre-fractured object, and the fracture modifier has a utility inside to hide inner edges too. So while being in the fracture modifier panel, you will find auto hide. So if you type something like 0.001, you will see it will hide this. Looks not perfect yet. Maybe you have to play around with these settings too. But I'm sure if you take a little bit time to play around with this, you will find your perfect settings. But very important here is don't use auto hide before you simulate water. Okay, so this is something you can do after all bakes has been finished. Okay, so that it's back to 0, very important. And remove the edge split modifier, really important too. The rendering stuff can be done in the last step. Okay, so yes, we are ready for our fluid simulation. So what we have to do, oh no, one more thing. We could say this bullet should be slowed down by the glass, so that would mean we have to rebake our simulation yet. I'm sorry, I forgot. So let's click on freebake here, and let's say this bullet is flying into this glass here, and make a keyframe from that animated box here while clicking I on a keyboard. And when this bullet is inside the glass, disable this checkbox and click I again. So what Blender does now is it converts your keyframed object into a dynamic physical simulated objects while being inside the glass. And that would mean when we're going to simulate or bake this again, our bullet is not flying in a strong line because it was keyframed. Now it will fall down to the ground like it would do in reality too. Okay, believe me, this will look fantastic. So play the animation and see what is happening. Yes, there we go. This is something I really like. So let's bake it again. Bake all physics. Wait for it to being finished. %100 done. Let's recheck if it is working like we would like to see it. Yes. Okay, so save it again. Save over. Yes, I want. Okay, and now we can prepare our fluid simulation. Okay, very easy because let's start with the bullet. That should be an obstacle that is moving the water. So click here and you can close this panels here, and let's click on flip fluids and say you are an obstacle. Make sure you have enabled the export animated mesh checkbox here. Yes, and that is all. Now go to the glass. Make the same thing here too. Let me close this. I remember there was a hotkey to close all tabs here or panels here, but I don't remember what one this one. So if someone could tell me, please write to the comment in this video. Flip fluids, make that one an obstacle. Make sure export animated mesh is enabled too. And one hint here is we have that expand field here, and this is really important. It is really great that we have it here, because let's say this glass would be real and you would make water into it. As it is pre-fractured, that would mean the fluid will come through all that cracks here, of course, because there are cracks. But by using this expand field here, the flip fluid simulator will make all pieces invisibly become bigger, just for the simulator. That means all the edges will overlap here to make it, yes, to avoid that fluids can come through the cracks here. Alright, but that is not visible for rendering, but an important thing for the simulator. So let's try to do it with low value or something like 0.2. As I told you, you will not see it, but the simulator will really need this. And yeah, so this had been set up, and now we will talk about the outer glass thing here. Okay, so one thing is we have to move it over here. Yes, I think it should look it should match as good as possible. So let me take a little bit time to do this. Okay, something like this, something like this. Okay. While scaling it down, up and down, you can see and make sure that it is inside your glass. And let me also move it down and up. Okay, so all right, this is the correct setup. Okay, so this one is an obstacle too. So I'm going to tell this simulator, hey, this is an obstacle. And you don't need to use the exported animated mesh checkbox here too, because it isn't animated. And while this thing is enabled, it will hold the fluid inside. And what we are going to do with this trick is as soon as possible, when the bullet is hitting our glass, we are disabling this obstacle, and then it will be not used for the simulator for this time. So very easy. Let's go to this frame, like I would say like here, just before the bullet is inside the glass. Make a keyframe here and jump one frame forward, so where you can see the bullet is inside the glass, and disable that one here, set a new keyframe, and from now the outer glass obstacle is not working, and the flip fluid will use only the glass and all that pieces for the final simulation. Okay, so this had been set up too, and we can hide this. This is not really required yet. And yes, of course, we need some fluids inside. Select this, press Shift S and cursor to selected to make sure we are in the center of our glass. Shift A and let's make a new cylinder. And top view, I'm going to rescale it to be inside our glass as good as possible. The wire view, scale it in this direction here. It must not be really fill the whole glass. So I would say yes, that could work. Okay. And let's say this is fluids inside, and of course flip fluids, and make that a fluid object. All right, this has been set up too. And finally we need a domain, so let's take a cube here, scale it to our needs. Remember, the bigger your domain is, the longer simulation will need, so make sure your domain is not bigger as required. Scale it, so something like this, and it's not a problem if an obstacle flies from out of the domain box inside the domain hub. It's not a problem. Also, it's not a problem if some pieces that are obstacles will go through the domain's walls to the outer space. The simulator can handle this without any problems. Okay, so yes, that looks good. Flip fluids, let's make that one become a domain. Okay. And let's talk about some settings here. You can see use frame rate. It took our settings from the start of this tutorial, so nothing to change here. I would say a preview resolution of 100 will work, and the general resolution is an interesting thing now, because the higher you choose to simulate this thing, the better the final result will be, and the less fluid will come through the walls here. So in the final simulation, I would say we should use a higher resolution. For some testing, we can choose a lower value, something like 100, and we should take a look to the flip fluid surface and make sure that subdivision 1 has been set, because that makes the fluid surface more stable, avoid flickering and something like this. We are not going to simulate whitewater this time. We are not going to change anything else. We are not going to use any preset yet. The material will be set after baking. Yeah, so I would say we can start simulating. Let me save the file again. Okay, and now let's click on bake to see what a first test simulation with these settings will look like. Okay, preview baking has been finished, and now let's see how this will work. So let me play the animation here. All right, so in the first look it seems like the fluids come through the glass, but as you can see, that is not happening. And now here is the point where our outer obstacle will be hidden, and yes, you will see that there's everywhere fluid coming through our glass. And that is not because we did something wrong here. It's what I told you. It is because the flip fluid simulator is not be done to use thin obstacles. And yes, to make that look better, the only thing we can do now is we use a much higher resolution. I would say we could use something like minimum 300, but for the final rendering you saw in the intro of this video, I used 1000 resolution. Of course, it's not really required, but you should choose some really high value here. Let's say something like 400 or like 500. So lastly, let's make sure we set everything correctly. We have expanded the edges here. We can try to use a little bit higher value, but that will not really help on thin objects. Make sure there's no edge split here. Make sure that auto height is not enabled, so there's 0. And if this is correct, we can go and start rebaking this with a higher resolution. Okay, so finally I'm back here. I finished baking my simulation, and I did some changes what I would like to tell you before we continue, because I had some issues. When baking has been finished, I just saw that there are many fluid particles are coming through the walls, and as I told you, this depends on how you're going to animate things and how big your obstacle is going to be. And what you need to do before your final bake is going to finish is let's have a look to the glass outer here. As you can see, I made it some bigger here. It is -1. And another thing is I changed the fracture modifiers setting here, or the obstacle setting here, to Hdri. And a very important thing is, as you remember, we animated the outer glass here to become an obstacle or to disable it, and I changed that keyframe to a later time. I believe it was here. Let me make that invisible glass. All right, here, and the fluids inside and the surface. Okay, so I've chosen another frame, and it was when the bullet is going to fly outside of the glass. As you can see here, this is a better moment to disable the outer glass for the simulation. Okay, these are the settings I just made before I rebaked the fluid simulation, and after that has been done, let me enable this again. Yes, and after I made these changes, I decided to take a resolution of 500 because it is a little bit better. And as you can see now here, it's not perfect, and believe me, you will never get it perfect because, as I told you, the flip fluid simulator is not made for that kind of simulation. So we are doing tricks here, okay? But that looks great. And of course, in animation, in a final animation, you may not see that small particles of fluid that are coming through here. So this is what we have now. And what I want to tell you finally is how to make these things look great for rendering. So I'm going to do this in the rendered preview. And the first thing, as you maybe remember, is we have to give the glass an edge split modifier. So the black parts are going away. So it's looking like this. And another thing is we need an inner glass material that matches the outer material. So just make this one glass 2. Otherwise you will have a diffuse material for the inner edges here, and it is not what we would like to see. And then go to the Fracture Modifier Utilities, and that is here, and enable outer hide 0.001 an example to hide the inner cracks, and then we are fine. It's looking like this. And let's jump to a frame where fluid is coming through. Let's say here, or maybe here. 50, yeah. Of course, because that is a huge amount of fluids that will take a while. I recommend to use the preview here. It will not look correct, but for working with it in the viewport, it is much better than the final viewport display. Okay, so what you need to do is after you have done the things I told you, you have to give your fluids another material. So whatever you like, you can choose to make that look like water. You can colorize it a little bit if you like, to look like something. Another great thing is to use an Hdri image as background, so you have beautiful reflections in your glass and in your fluids. And yes, so that is all. I hope you enjoyed this tutorial. I'm sorry it is not perfect. I'm working on new tutorials that will make things look better. The development of the Flip Fluids add-on and the Fracture Modifier is still in progress, and we try to improve the things as good as possible. But for this time it's all, and yes, I would love to see your results from this tutorial, and see you the next time. Goodbye, guys.